When was the last time you see a rainbow? Do you have any idea how rainbow is formed? So the keyword here is refraction, where light is refracted through water droplets in the sky, forming a rainbow. Rainbow is an example of continuous spectrum, where there is no definite lines between each color on the rainbow. Now, I am going to show you the formation of line spectrum of hydrogen gas. In this experiment, a light bulb is filled with hydrogen gas in low pressure. The light is turned off so that we can see clearly the lines formed by hydrogen gas. A diffraction grating is placed through the light, and we can see the spectrum shows three clear definite lines. This is what we call a line spectrum. This video shows the formation of Balmer Series, where we can clearly observe the three lines, which is red, green, and blue in color. I will explain how line spectrum is produced from electron transition. So, we all know from the Bohr's atomic postulate, when electron falls from higher energy level to lower energy level, it will release energy in the form of light. So kat situlah line spectrum akan terhasil. So let's look at this diagram. So this diagram indicates the electron transition. Electron fall from higher energy level to lower energy level. So this diagram shows 5 series of hydrogen spectrum. So there is Lyman series, Balmer series, Paschen series, bracket and Fan series. So Lyman is observed in the ultraviolet region. Balmer is observed in the visible region. So the video in the introduction part is actually Balmer series because it is observed in the visible region. So kita nampak dengan mata kasar. Next, we have Paschen, bracket and Fan in the infrared region, meaning that we can only observe this series in the under infrared light. Now let's look at Lyman series. So let's say we have this electron transition. All electrons fall to n equals to 1. So we have electron from n equals to 2 fall to n equals to 1. So actually this is it will form the first line of the Lyman series. Okay, so on the line spectrum, the first line is actually the one which is furthest from all the lines. So yang ni lah, ni adalah garisan pertama. So this is actually the first line of Lyman series. Now let's look at the next one. So this is the second line. So second line is actually produced when electrons fall from n equals to 3 to n equals to 1. So kat sini akan terhasil lah second line. Next, the third line. So the third line on the line spectrum is produced when electrons fall from n equals to 4 to n equals to 1. So cara nak kira senang je. Kalau contohlah kita ada third line of Lyman series. So kita tahu untuk Lyman series, all electron fall to n equals to 1. So 3 garisan atas n equals to 1, okay, 2, 3, 4. So the third line of Lyman series is produced when electron fall from n equals to 4 to n equals to 1. Okay, so benda ni bersambung je lah. Okay, untuk fourth line, fifth line, okay, kita ada 6 garisan, 6 transition kat sini, so dia akan menghasilkan 7 transition lah. So on the line spectrum, this is the fourth line, fifth line, sixth line, and this one is the seventh line. So kat sini yang penting ialah awak identify electron fall from where to where. Okay, so that we can do the calculation. Next, let's go to Balmer series. Okay, so yang ni pun saya lukis terbalik pula line spectrum dia. So the line spectrum, okay, the first line of the line spectrum yang paling jauh lah daripada garisan lain. So this is the first line. So first line dekat sini adalah when electron fall from n equals to 3 to n equals to 2. Okay, so untuk Balmer series semua elektron jatuh kepada n sama dengan 2. So ini akan menghasilkan first line lah. So sebenarnya line spektrum terhasil dulu. Barulah kita study dari mana ke mana elektron tu jatuh. Okay, so kita tengok pula the next line. So this one form the second line. Okay. So on the line spectrum, this is the second line. So samalah sampai sini, third line, okay, fourth line, fifth line, and sixth line. So yang penting kat sini awak kena tahu identify lah. Untuk line tertentu, untuk series tertentu kena tahu elektron jatuh dari mana ke mana. So for the third line, you can see here that electron fall from n equals to 5 to n equals to 2. So benda ni continuous je lah. Untuk fourth line, electron fall from n equals to 6 to n equals to 2 dan seterusnya lah. Semua pun elektron jatuh kepada n equals to 2 untuk Balmer series. Okay, so let's say kita ada fourth line of Balmer series. So kat sini untuk Balmer series, n equals to 2. So 4 garisan atas n equals to 2 ialah n equals to 6. So untuk fourth line of Balmer series, electron fall from n equals to 6 to n equals to 2. So let's go to the next one, Paschen series. So untuk Paschen series, semua elektron jatuh kepada n sama dengan 3. So kat sini pun sama, garisan yang pertama nak kenal pasti ialah garisan yang paling jauh daripada garisan lain. So this is the first line, the second line, okay, third line, fourth and fifth line. So the first line of Paschen series is this one here. Electron fall from n equals to 4 to n equals to 3. And then this one form the second line. Okay, electron fall from n equals to 5 to n equals to 3 and so on lah. Okay, fourth line. And we have the fifth line. Electron fall from, okay, ni infinity lah dia buat. Okay, to n equals to 3. So kat sini let's say kita ada second line. Okay, nak cari second line of Paschen series. Okay, so untuk Paschen series, all electron fall to n equals to 3. So kalau second line, maksudnya dua garisan on top of n equals to 3, it means that n equals to 5 lah. So second line of Paschen series is formed when electron fall from, okay, n equals to 5 to n equals to 3. So now let's go to the calculation problem. So kat sini kita ada dua jenis pengiraan. Bila elektron tu tak bergerak, okay, when electron is at certain energy level, so you have to use equation 1. Okay. And then bila elektron makes a transition, maksudnya elektron jatuh. So kat sini kita boleh kira dia punya delta E, okay, lambda dan juga frekuensi. Kita boleh kira tiga benda lah bila elektron tu makes a transition. So we can use equation 2, 3, 4, 5. Okay, so kat sini beza antara equation 2 untuk delta E and equation 4 untuk delta E. Okay, for equation 2, we know the transition of electron. Kita tahu nilai N. So, you can use equation 2. Okay, but for equation 4, kalau kita tak tahulah nilai transition dia. Nilai N untuk elektron tu. Tapi, jawapan akhir tetap samalah. Okay, so please be noted that for this calculation, there are 4 constants. Untuk Rydberg constant ada dua nilai. Okay, satu untuk energy, the unit is joule. The other one is for lambda, the unit is meter negative 1. So, the wavelength that you will get in this formula is in unit meter. Okay, so pastikan nilai kat sini N1 mesti lebih kecil lah daripada N2 supaya kita dapat nilai lambda yang positif. Tapi untuk equation 2, kita ada initial and final kat sini. So, awak kena identify lah sama ada elektron jatuh ataupun lompat. So, when electron fall, the value of delta E will be negative. Okay, tapi bila elektron jump, so kat situ delta E dia akan jadi positif lah. And then we have Planck constant. Okay, so Planck constant ni kita guna kalau kita guna equation yang kelima ni. And then speed of light pun sama kita guna kalau equation yang kelima. So kat sini pun kita ada relationship antara delta E, lambda and frequency. So we can see here delta E and lambda is inversely proportional. So yang ni kena masukkan je lah nilai dalam equation untuk buat pengiraan. Okay, now let's go to example 3. So example 3 is in your module for a second line in the Balmer series of a hydrogen spectrum. So dari sini kita boleh kira macam-macam lah. So kat sini soalan suruh kira wavelength, frequency and the energy. So first we have to identify second line of Balmer series ni merujuk kepada apa. So for Balmer series, we know that all electron fall to n equals to 2. So second line on top of n equals to 2 is n equals to 4. So kat sini kita tahulah the n initial is 4 and the n final tu tempat di mana elektron jatuh lah is 2. So for the calculation, you just have to insert all the values into the formula. So to calculate the wavelength, since we know the value of n, so you just substitute the value of n into the formula. Okay, please use the correct Rydberg constant. Okay, guna yang unit m-1 lah untuk cari lambda. So finally, you will get the value of lambda in meter. Tak tukar ke nanometer pun tak apa. Kalau soalan suruh tukar, baru tukar lah. Next, to calculate the frequency, so you can just use this equation here. Since we the value of lambda, so masukkan je nilai. So you will get the value of frequency in S -1 ataupun boleh juga letak sebagai hertz. Dua pun boleh. The last one, energy. So kat sini awak boleh juga guna equation yang melibatkan n ataupun since we know the value of frequency, kita masukkan je lah nilai frekuensi dari soalan B. Dua-duanya tetap akan menghasilkan jawapan yang sama. Tapi kalau awak guna equation ni, kita akan dapat jawapan positif. So awak kena letak dalam bracket lah energy is released ataupun awak negatifkan nilai tu sebab elektron jatuh. So when electron fall, so it will release energy and the value of delta E must be negative.